We have our incomplete version of the project from the downloaded assets. And what we're going to do is we're going to start by adding our second camera, which is going to follow the player. So we're going to open in the Minimap folder, our prefabs folder, and we have this complete player tank prefab. And we're going to drag that into the scene and position it at 0. At 0, 0, 0 on the X, Y, and Z or Z. And so what we're going to do, we're going to expand the hierarchy for the player, and then we're going to right click on the player and we're going to choose camera. This is going to create a new camera. We can see that our game view updates. We have a little error in the console, which is an error related to the Unity editor, not related to the content that we're working on. We're just going to clear that. And so currently our camera has come in, and if we zoom out, we can see its view frustum. It is positioned between the tank's treads, peeking out along the ground. That's not actually where we want it. So what we're going to do is we're going to, with the camera selected, we are going to position it 50 units above the playing field. And then we're going to rotate it 90 degrees down on the x-axis. So now it's 50 units up, pointing down at our level. And let's label this camera. We're going to call this Minimap camera. All right. So this camera is going to render the view that is going to go into our Minimap. And currently, this camera is in perspective mode, and we can tell that in a couple of ways. One, we can see the view frustum of the camera, this kind of pyramid shape projecting outwards from the camera. And this is showing us what is visible to the camera, right? Anything inside this pyramid is going to be visible to the camera. And because it is in perspective mode, if we frame select it on the camera, we can see here this near rectangle is what's called the near clip plane, right? And this is the closest thing that the camera can see. And then way, way out here, in this case, 1,000 units away, we have the far clip plane, which is this huge rectangle, which represents the farthest extent of what this camera can see. So this is giving us a 3D view of our scene in perspective mode. But actually, because we want to render this into a map, we actually want to create more like a 2D view, a top-down 2D view of our scene. And so what we're going to do is we're going to switch the projection mode of our camera from perspective to orthographic projection. And we can do that over here by toggling from perspective to orthographic. We'll see that the view changes, right? It seems to get much closer. And we can also see that the view frustum has changed, right? Instead of having this kind of pyramidal shape, it now has parallel lines and a kind of a rectangular cube shape projecting downward from the camera. And so we end up with this kind of long, thin box. And you'll notice that the far clip plane and the near clip plane are actually the same size. And so what this does is gives us a kind of a flattened view of our scene. So I have some little graphics that explain that. So in perspective mode, when we have a perspective camera, objects within the camera's frustum are rendered, right? This is true of both perspective and orthographic cameras, but the shape of the frustum is different, right? So in this case, we can see the frustum is the orange shaded area inside of our kind of projected pyramid. Anything inside this shape will be visible. What's different between a perspective and an orthographic camera is that objects closer to the near clip plane appear larger in the perspective camera and grow smaller as they move further away. Now this is strange to explain, right? Because this is familiar behavior. This is the way our eyes work as well, right? So if something is close up, it appears large, and if it's further away, it appears small. This is not, however, the case with an orthographic camera, which we'll see in a moment. So in order to zoom in or out the perspective camera, we can move it closer or further away from the subject. And perspective projection is the default setting for 3D cameras in Unity. So if you make a new 3D camera and the editor is in the 3D mode, it's going to create a perspective camera. Now, an orthographic camera is like the perspective camera in that only objects within the view frustum will be rendered, but we can see the frustum has this kind of cube-like or rectangular cube-like shape. Objects appear to be the same size at any distance from the near clip plane to the far clip plane. So more distant objects do not appear smaller, and this is kind of one of the main differences. And so in order to zoom in or out with an orthographic camera, we use the camera's size property. And this is the default setting for 2D cameras in Unity. So we have changed our camera's projection mode to orthographic, and what we want to do now is adjust the size. So if we adjust the size, we can watch the shape of the view frustum change in the scene view, and we can see the camera's view changing in the game view. So what we're going to do is we're going to zoom this camera way out, and let's go out to about a size of about 30. Right, so this encompasses our entire level, or a good chunk of our level, and will be useful for our map, right? Because we want our map to have many things visible. Now, we have a canvas that's currently turned on. I'm actually going to temporarily turn it off. We'll turn it back on later, but just so we can see the unobstructed view. So we can see we have this tiny tank in the middle of the scene. Now, I just want to demonstrate something kind of interesting about orthographic cameras. If we move this camera up and down, let's set the scene view so we can see it move. If we move this down, notice that the game view does not change, right? Which is kind of weird, but this is the way it works. But what will happen is if our camera gets too close, you can see it will start to clip into the scene geometry, right? Because now the near clip plane is actually lower than the scene geometry, and we can go all the way down and do this kind of weird sectional slice into our level with the camera. And importantly, right, even though the camera is not in perspective mode, nothing that is not inside the view frustum will be rendered, right? So it's important to make sure that when you're using an orthographic camera that it's positioned in such a way that everything that we want to render is going to be inside the view frustum. Okay, so now we have our second camera set up. We have our sort of flattened, top-down, 2D-like view of our 3D scene. The next step is going to be setting up some little icons to render on the Minimap and also get our cameras working, rendering the things that we want them to. Rames44B asks, in this application, is there an advantage to pulling the far clipping plane way in? That's a good question. The only thing that I'm aware of with that is if you have very, very long distances, much longer than the 1,000 units that we have here, and there's a very high, very large distance between the near and far clip plane. I'm talking more like 100,000 or 200,000 units. You can start to see some artifacts because you have less, you're losing precision by having such a large depth between the two planes. So you do want to keep your distance between your near and far clip planes sort of within a reasonable bounds. The default in Unity is for the near to be at 0.3 and the far to be at 1,000, which is way more than we need here, but I don't see the need to dial it in because we're only dealing with a distance of about 1,000 units here. Generally speaking, the reason you would adjust your far clip plane is the greater the distance of the far clip plane, the more stuff is in the view frustum and the more stuff you're having to render. So if there were, let's say, lots and lots of geometry further away in the level in the distance, and we wanted to clip that out and not render it for performance reasons, we could effectively lower our draw distance, right? Bring the far clip plane closer to render less stuff. that can be a appropriate thing to do in certain situations. Yes, as Oscar Russo says, you get better precision on the Z buffer. That's, I think, what I was looking to say. But yeah, as Piflick says, in this case, it really doesn't matter. That's a cool use. As GM Liquid Media says, if you have multiple 3D levels stacked, you can use the clipping planes to show floor 1, 2, or 3. That would be kind of fun, right? You could move the clipping planes up and down to just render certain things. That's a cool tip.